In this video, I'll show you how I made this cool vintage-looking LED strip controller using mostly pieces from two cheap analog multimeters. I started by figuring out how to connect the LED strip and get different color temperatures. After some experimentation, I found out that we can change the temperature by connecting different pins to ground. Now it was time to fix the strips in place. For that, I 3D printed some custom supports in the wood filament to blend better with the shelf, and fixed them with screws. I was now ready to test the new illumination. With the LED strips in place, I started working on the controller. I used two analog multimeters as the base for the build, and ended up reusing most of the internal circuitry and body. I started by separating all of the components and pieces that I was going to use. It wasn't too difficult since this kind of multimeter is pretty simple. I also removed the labels and carefully extracted the nail piece. I cut the unnecessary inner parts of each multimeter body to make room for the electronics. It wasn't too hard to do with a simple rotary tool, but it requires some patience and care. Once I had enough room inside, I glued both multimeter bodies together to start forming the final shape of the project. Then, inspired by vintage analog meters, I also cut some LEDs from an LED lamp, keeping one resistor per LED so I can use them for the panel illumination later. To figure out the polarity of each LED, I used a multimeter in continuity check mode and connected the probes to each connection of the LED piece that I cut. If the LED lights up, it means the polarity corresponds to the colors of the probes of the multimeter. I then measured the distance at which I wanted the LEDs to be on the top of the panels, and soldered them in place with some cables. And of course, made sure everything was working. With the shape of the controller defined, I designed and 3D printed a shell using the bronze filament. Once sanded, this filament will shine a little and simulate a metal chassis for the project, giving it a more industrial look. While the shell pieces are printing, I started working on the circuitry. First, I used some hot glue to cushion support for the potentiometers that will control the luminosity and temperature. I cut a little piece of perf board for each potentiometer and drilled holes for two screws. Once I found the screws with the right size, I fixed each piece in place, screwing directly to the hot glue cushions. I then tested out with the potentiometer part that I 3D printed to see if the placement was correct. It was now safe to solder the potentiometers in place. But, when trying the second potentiometer, the small fit broke and it got stuck in the potentiometer hole. Since I was improvising this whole project from the start, I quickly came up with an alternative solution. I cut and bent the battery supports into little fits that I then fused with the original multimeter mode selection wheel piece. Once that was tackled, I sanded the shell pieces and increased the thickness of the enclosure body to fit them using hot glue. Next, I soldered some female headers to the microcontroller. The plan is to be able to disconnect it from the circuit and keep a non-destructive approach to the build. That is, to be able to replace the different pieces as easily as possible while keeping the relatively small size. To accommodate the circuit inside the box, I had to get handy using some wire to mold the connections and the components to the shape of the enclosure. It was a bit of a lengthy process since I had to measure and solder, and repeat for each branch of the circuit. Then I realized that having to disconnect the microcontroller every time I needed to test if the code was working during development was not viable. So I soldered an extension to the USB pads to allow me to reprogram the controller without having to reopen it. And for each connection that goes in and out of the enclosure, I had to mark the dimensions and cut the holes, since I didn't account for that in the design of the 3D printed pieces. And finally, it was time to reassemble everything. But I still needed to fix the controllers to the wall, so I marked two positions on the back piece that didn't interfere with the circuit and drilled some holes. Then I drilled the corresponding holes in the wall. Two quick tips here are that you can use some tape to mark the drill bit and avoid drilling too far, and tape a little paper pocket below the drilling zone to catch the dust. I also added some electrical tape over the screws to isolate them from the circuitry. And finally, it is time to put everything together and try it out. As you can see, everything is working properly by rotating the potentiometers to adjust both the luminosity and the temperature. You might have also noticed how the panels don't actually have any labels. That's because they're inspired by sci-fi movie control panels, which are many times very minimalistic, and I actually really like this style. The connection to the LED strips is done using wire, and I 3D printed some separators to ensure that each wire isn't touching. I then created the USB cable needed to program the microcontroller. And for power, I used a 12-volt 2-amp transformer. And that's it. I hope you've enjoyed this project and learned a lot. If you wanna be the first one to know about more projects like this, subscribe to the channel and don't forget to activate the bell notifications. Thanks for watching.